Hi class, this is Sir Alex Basco again and welcome to our lesson in General Biology 1. We are continuing on with our discussion with active transport mechanism or transport mechanism in the cell, but we are focusing on active transport in our lesson 6.3. So for the goal of today's lessons is for us to be able to explain transport mechanism in cell, but this time we are talking about active transport. Our lesson previously we dealt about passive transport, which is the transport of molecules inside of or out of the cell, and passive transport does not need energy. But for active transport, today is we will discuss what happens in active transport. So let's begin with understanding the basic of active transport, which is it needs energy. There is an essence or there is a need for the use of energy in order for the cell to move substances across its membrane. Um, if you guys remember, the membrane of the cell is semi-permeable. Not everything can cross it. Um, and the cells often requires things to help substances move across its membrane, especially when we are dealing with ions. Ions cannot just easily permeate or cannot easily pass through the selectively permeable membrane of the cell. So meaning ions from the extracellular fluid cannot easily flow inside the cytosol. In order for the cell to take the needed ions inside and push out the unneeded ions outside, the cell needed energy in order to move those ions. Also, in active transport, there are two categories of cell, or there are two categories of active transport. One being the primary active transport, wherein there is a source of chemical energy, and that chemical energy is usually in the form of ATP or adenosine triphosphate. Adenosine triphosphate is a molecule created by the molecular metabolism, which we will actually also discuss later on in our quarter on how the cells create ATP. But for intents and purpose of this class, just remember that primary active transport uses ATP to move substances in and out of the membrane of the cell. Then there's what we call secondary transport. When the cell creates an electrochemical gradient, an energy is stored, and that stored energy can be used by proteins and molecules to actually move molecules across the membrane. We'll later discuss more about secondary, but just remember if it's for secondary, we don't. You just have to remember that there is no need to use a chemical energy ATP, but we use a different source of energy. Most of the time, we use the energy stored in the electrochemical gradient. But you might be questioning now, what is electrochemical gradient? Ano ba yung electrochemical gradient? The membrane of the cell or the cell is actually more complex than what we've discussed in passive transport. If you guys remember in passive transport, we discussed what we call a uh, there you go. We discussed what we call a concentration gradient. Concentration gradient, if you guys remember, let's write it here. Concentration gradient is basically the movement of molecules from high concentration to low. We've discussed this, that the molecules and solutes always would move from the concentration of high concentration to low concentration. This is what we call a concentration gradient. And the cell is more complex than the simple concentration gradient wherein diffusion happens. The cell, because the body or the atoms can create what we call ions. Ions or atoms or molecules that contains that are charged. They can be positively charged or they can be negatively charged. And our body is actually full of ions. Well, one of the most common Some of the most common ions that our body has are sodium ions, potassium ions, and chlorine ions. So we have positively charged sodium and positively charged potassium inside our body, as well as negatively charged chlorine. And because there are some charged particles inside our body, there's two types of gradient that is actually working on the membrane. Not only concentration gradient, but an electrostatic gradient. So electrochemical gradient is basically a combination of two gradient. Chemical gradient being the concentration gradient, wherein we move molecules from high to low. And then there's also an electrostatic gradient. An electrostatic gradient is very simple. It's something that we're already familiar about. Electrostatic gradient is simply the idea that um, same charge are being repelled, while unlike charge are being attracted. So these two gradient or these two processes are actually happening across the membrane. So let's look at this. So this area right here where is blue is ACF or extracellular fluid. It's the fluid outside of the cell. It's our ACF. Our ACF is actually positively charged, or it's relatively positive compared to the inside of the cell. So the inside of the cells, or the ICF, intracellular fluid, or the cytoplasm, is negatively charged relative to the positively relative to the outside of the cell. Another thing that is different between the two is in the ECF there is a higher concentration. Uh, see, there's a higher concentration of sodium ions. For ECF or ICF, the cytoplasm, there's a lower concentration of sodium ions. Another thing is for in the outside of the cell, there's actually lesser concentration of potassium and there's a higher concentration of potassium. So now let's look at what we call an electrochemical gradient. Electrochemical gradient is basically the establishment of the gradient or the movement of the particles based on concentration gradient and electrostatic force. As for the concentration gradient, part of the electrochemical gradient, sodium would always want to go inside the cell. The reason for that is because of concentration gradient, there is always a higher concentration of sodium compared to the lower concentration of sodium. And from concentration gradient, we learned that there's always a movement from high to low. But for potassium ions, they always want to move relative to outside of the cell. Okay, so for potassium, we usually want to move outside of the cell based on concentration gradient. The reason for that is for potassium has high concentration, while outside potassium is low. So we've learned about that, and I hope that is clear. Tama? That's just concentration gradient. But that's not only the force acting on these ions. There's also what we call the electrostatic force. In the electrostatic force, because the inside of the cell is negatively charged, potassium ions, or let's begin with sodium ions, would usually want to go inside of the cell as well. So for the potassium, there's two forces acting, forcing them to go inside the cell. That is the concentration gradient and the electrostatic force. So sodium would always want to go inside the cell if there is a way for it to go inside. If, for example, there's a channel protein that opens for it to go inside, it will go inside because we have concentration gradient and electrostatic force forcing the sodium to go inside. But for potassium ions, it would always want to go because the cell is positive, or because the inside of the cell is also negative, it also wants to go inside of the cell, which is opposite in the direction of the potassium, or it's kind of opposite on the direction of its concentration gradient. So because the inside of this cell is mostly or negatively charged, potassium would also want to go inside. But we know that there is a higher concentration of potassium inside, so meaning the concentration gradient would always want to move potassiums outside of the cell. So let's invert this para hindi siya nakalito. So we have potassium inside and it always want to go outside the cell. So these two concentration gradients are working on these ions, creating a what we call a membrane potential. This membrane potential is the result of a difference in the charge of the cell. Uh, because of the electrochemical gradient, uh, or the forces acting on these ions, and again Na always wanting to go inside of the cell because of concentration gradient and electrostatic force, while for sodium wants to go outside of the cell because of concentration but wants to go inside the cell because of electrostatic force. This combination of electrochemical gradient results in a membrane potential wherein there is a separation of charge between the outside and the inside of the cell. The outside of the cell has a more positively charged is more positively charged compared to the negatively charged um, compared to the negatively charged cytoplasm, or the negative status of the inside of the cell. So how is this electrochemical gradient established? So how does the cell establish this membrane potential, this difference in negatively charged? And that is through what we call transport. The cell has to manage to transport the cell, or for the cell has needs to find a way in order to keep the concentration of sodium and potassium uh, kind of like constant. So as you can see, if sodium always want to go inside the cell, bakit mas marami pa rin sodium sa labas ng cell? Bakit mas marami pa rin yung concentration niya if ang gusto ng sodium is always pumasok sa loob ng cell? And bakit yung potassium mas marami pa rin siya sa loob ng cell kung yung movement niya is kind of like balance between going inside and going outside. And that can happen because of active transport. And active transport is necessary to keep this balance, or to keep these concentrations of potassium and ions relatively constant. And because of this transport, the cell keeps a membrane potential, that difference in the charge. And this is necessary to a lot of processes in the cell. This negative separation, or this separation of charge, is important because, for example, sa mga neurons, the neurons will not be able to activate, meaning we cannot feel, we cannot think, we cannot move our muscles if there is no membrane potential. So now let's go on how does the cell establish this electrochemical gradient. So it establishes it by form of primary active transport called the sodium-potassium pump. Sodium-potassium pump is basically how uh, the cells pump sodium out of the cell and pump potassium inside the cell. So let's talk first about this pump. So the cell needs to use energy to move substances against their concentration gradient. The cell uses what we call electrogenic pumps to establish and maintain its membrane potential. If you guys remember, Na would always want to go inside of the cell kasi there's a higher concentration sa labas, so lagi silang papasok sa loob. And dahil negatively charged yung loob ng cell, lagi silang papasok sa loob ng cell. Yung sodium potassium pump, ang ginagawa niya is it moves sodium out of the cell. So that is a negative, that is not negative, that is the opposite direction nung electrochemical gradient niya. Para magawa yun ng cell na para makick out niya yung mga sodium palabas, kailangan niya ng energy para yung movement ng sodium is opposite dun sa natural movement niya via electrogradient. Same thing sa potassium. Ang potassium, kaya ang gusto ng cell is laging magpasok ng potassium sa inside para ma-establish yung very high concentration ng potassium inside para dahil mas mataas yung concentration ng potassium, naturally nalalabas yung potassium sa ECF kasi from high concentration to low concentration, tama? Potassium mas mataas sa loob ng inside ng cell, and the reason for that is because of the sodium potassium pump. Potassium ions would always go into the cell, and the chemical constant or the chemical gradient will push out this positive what do you call this, will push out this positive potassium outside of the cell. Moreover, dahil dumarami rin yung positive na potassium sa loob ng cell, dahil sa electrostatic force din, positive, lalabas din it will repel. So it will kick out the potassium outside of the cell. Okay, so I'm not sure if I explained that clearly, pero overall, basta ang ginagawa ng sodium potassium pump, it establishes the membrane potential by kicking the sodium out of the cell and pumping potassiums inside the cell. So how does it do that? Via a carrier protein. This is a type of carrier protein, this pump right here, called the sodium potassium pump. So the process starts with the pump. Yung unang position ng pump is that it is inside, facing open inside the cell. So mapapansin nyo, yung potassium pump, yung natural orientation niya or natural shape niya is nakabukas siya sa loob ng cell. This is the ICF, this is the cytosol, this is the extracellular fluid. Kapag nakaganito siyang orientation, it has a high affinity to sodium. So it means the sodium would bind to the pump. And also, in this configuration, ATP will also bind doon sa ating sodium potassium pump. So when three sodiums finally bind dun sa ating pump that is still open inside, phosphorylation will trigger. What we mean by phosphorylation is yung ATP ito na naka-attach dun sa ating pump will hydrolyze the ATP. Yung pump natin will hydrolyze the ATP, meaning it will break down yung one phosphate group dun sa tatlong phosphate. So mangyayari, may iwan yung isang phosphate doon sa ating pump. And then, matatanggal yung adenosine diphosphate. Diphosphate na lang, ADP, kasi dalawa na lang yung phosphate na natira. So yung isang phosphate group may iwan dun sa pump kasama ng tatlong nakabind na sodium. So that's what we call a phosphorylation kapag nag-breakdown ito. So this happens after na yung sodium mabind dun sa ating pump. So when three sodiums bind onto the pump, phosphorylation happens. And what the phosphorylation does is it changes the shape of the pump. So when the phosphorylation happens, it will change its shape by opening itself to the outside of the cell. So kung papansin nyo, after phosphorylation, nag-iba yung shape niya. So magbubukas siya sa outside ngayon and magko-close siya sa loob. Kapag nag-change na yung shape ng pump, what happens is it will lose its affinity to these three sodium na nakabind. So when we say lose affinity, it will not like to bind to sodium anymore. And when that happens is it releases the sodium to the ECF. Okay, so that's how the cell basically transport sodium out of the cell, which is the opposite dun sa natural tendency ng sodium na pumasok sa loob ng cell. Kasi nga, so yung sodium, mas mataas yung concentration sa labas, so lagi niyang gustong pumasok sa loob. Moreover, dahil mas negative dito, mas lalo niyang gustong pumasok. So ang gagawin ng cell, in order to keep the membrane potential and the electrochemical gradient, it will pump sodium out of the cell. So after na mangyari yun, na matanggal na yung tatlong sodium, ma-release na sila sa ECF, yung bagong shape ng cell ng pump na still na nakabukas sa outside, it will have a very high affinity or would like to bind to potassium. So it will have this new shape of the cell that is open on the ECF will have a high affinity to two potassium ions. What that means is that two potassium ions will bind onto the pump, and after the binding, the phosphate group would actually be released. So when the potassium binds onto this pump, potassium or phosphate, the phosphate group that is attached in the pump will be released. And when that phosphate group is released, it will go back to its original shape, wherein it will become a pump again that is open inside. And when it returns to its original shape, it will lose its affinity. It will lose its affinity sa potassium, and the potassium would be released inside the cell, and then the process starts all over again. So this is the transport. This is how the cell transport sodium out of the cell, which is the opposite ng direction ng concentration and electrostatic gradient niya or electrostatic gradient niya. And it will also, this is also how the cell pumps in potassium inside, creating a very high concentration of potassium inside the cell, which then will result in the concentration gradient or the sodium or the potassium moving from inside to outside. So this is how the cell establishes the electrochemical or maintains the electrochemical gradient and establishes the membrane potential. So that's how the cell establishes a more negative inside and a more positive charge outside of the cell. So that is an example of primary active transport. The sodium-potassium pump is one of the most popular primary active transport mechanism ng cell. Yun, so K is released inside. So what is a secondary active transport? So secondary active transport naman is electrochemical gradient na sinetap ng primary active transport stores energy, which can be released as ions move back to their gradient. So ito yung kanina, no? This is our carrier protein that does the sodium. This is our sodium potassium pump. So nangyayari, so, potassium would go inside while sodium would go inside. And remember, the outside of the cell has a very high concentration of sodium. So from our electrochemical gradient, this sodium would always want to go back inside the cell because there is a lower concentration of sodium inside. And in order for the cell to, when that happens, this sodium, as it moves back down to its concentration gradient from high to low, it also carries with it another substance, and yung substance na yon is what we call a glucose. Okay, So this is what we call now a secondary active transport. Secondary active transport is because the concentration gradient, according to the concentration gradient, Na would want to go inside the cell kasi mas konti yung concentration niya dito and high yung concentration niya dito. So there is energy in that. There's a store energy in that movement. And as Na goes inside the cell, in this, for example, in this type of protein, it will carry itself to Na would carry a glucose. Okay, so magbabind siya sa dalawang or yung dalawang Na, magbabind siya sa dalawang glucose. Not technically magbabind, pero parang isasama niya yung glucose papasok sa cell. And this glucose entering inside the cell using the energy of the concentration gradient of the sodium is called a secondary active transport. So I hope that is clear. So again, dahil nag-pump tayo ng sodium palabas sa cell, mas mataas yung concentration ng sodium sa labas. And from the electrostatic gradient or electrochemical gradient, the sodium would want to go from high concentration to low concentration. So high sa labas, low sa inside. So Na would go inside the cell. And there is a stored energy in that movement. That's like parang kinetic energy yan. Kasi pumapasok siya. And ang gagawin ng glucose, it will use that gradient, that energy stored in that gradient para makapasok din siya sa loob ng cell. So the protein that transfer both two different chemicals papasok sa cell is what we call a symport. So symport is basically a type of movement caused by carrier proteins na magmo-move yung dalawang molecules on the same direction. Pwede silang papasok or pwede silang palabas. That's what we call a symport transport. Ang antiport naman is parang yung sodium potassium pump kasi yung isa papasok, yung isa lalabas. There's another one what we call a uniport. Ang uniport naman is isa lang ang pinapasok niya, either papasok or palabas, and laging isa lang. Ayun yung mga carrier proteins na pinag-usapan natin, halimbawa yung aquaporins, parang pinapasok lang niya is water molecules. So that's an example of a uniport, isa lang yung pumapasok. Pero kung dalawa siya, is a type of a secondary active transport wherein it uses the energy from the electrochemical gradient or it uses ATP. Ang difference is ang antiport is yung isa papasok, yung isa lalabas. While yung symport, yung dalawa papasok or yung dalawa lalabas. So I hope that is clear kung ano yung difference ng primary active transport and secondary active transport. And these are some examples of active transport. These are example of an active transport. So hindi pa tapos yung active transport. Our next discussion is another type of active transport called vesicular transport or bulk transport. And we're gonna stop here muna in our discussion of secondary and primary. Yung vesicular transport will be our next lesson. So I hope that is clear. I'm not sure if medyo na-explain ko na maayos, pero kung meron mga confusion or mga question, please do not hesitate to message me and ask po, okay? And I hope you guys have a great day and thank you so much.